Students, can you tell me that up to which question we have done in our previous classes? I think it was question number 9. Today from question number 10, yes. Today we'll start from question number 10. And the exercise number is 10.2. Okay, so let's read the question 10. Prove that the angle between two tangents drawn from a external points to a circle is supplementary to the angle subtended by the line segment joining the points of contact to the circle. Okay, so let's draw a circle first. Take a point, draw a circle. Okay, so this is the circle. O is the center of the circle. Take a point, any point outside the circle, and from that point draw two tangent. One tangent is suppose PA and one tangent is suppose PB. Then joining the point of contact with the center. This point and join these 2 points. What we have to prove? We have to prove that this angle and this angle are supplementary to each other. Means angle AOB and angles APB are supplementary to each other. Okay. Now how we can prove it? Now look, we know a theorem that if we consider a circle with the center O, let this is a tangent at any point A. O is the radius through the point of contact. Then the tangent and the radius through the tangent, the angle between the two lines is 90 degree. Now look, from the point P we have draw a tangent PB. And what is OB? OB is the line, OB is the radius through to the tangent. So obviously this angle must be 90 degree. Similarly, PA is the tangent and AO is the radius through the on to a tangent. Okay, so this angle will also be 90 degree. Clear? So first write these two things, that as a PB and PA are the tangents and OB and OA are the radius, through the tangent, Therefore, angle OBP will be 90 degree and angle OAP, this angle will be also 90 degree. Okay. Now look at the diagram AOBP. Obviously this is a quadrilateral. Now if we apply the angle sum property of this quadrilateral, we have what the angle sum property of a quadrilateral, that the sum of all interior angle of a quadrilateral is exactly, so no, this is 360 degree. So in the quadrilateral, the name of the quadrilateral is AOBP. Apply the angle sum property. Angle O plus angle B plus angle P plus angle A. This value must be equal to 360 degree. That means angle O plus angle B, value of B is 90 degree. It is known. Plus angle P, we don't know the value, and angle A is again 90 degree, which is equal to 360 degree. That means angle O plus angle P is equal to 360 degree minus 90 degree plus 90 degree. Okay, now do the calculation, you will have your answer. That means 360 minus 90 plus 90, that is equal to 180. 360 minus 180, that is equal to 180. Means angle O plus angle P is equal to 180. And we know that if sum of two angles is equal to 180 degree, then the angles are said to be supplementary angle. That means here this angle APB and this angle AOB are supplementary angle, and hence the proof. This is the proof. Now tell me, students, have you understood? If you have any problem, you can tell me. Otherwise, we'll go to the next question. No problem. That's a good. Okay, now let's go to the next question, question number 11. So I am rubbing it. Question number 11. Question number 11 is prove that the parallelogram circumscribe a circle is a rhombus. Means if a parallelogram circumscribe a circle, then we have to prove that parallelogram must be a rhombus. Okay, so let's draw a circle first. Okay, so this is our circle with our center A, and now draw a parallelogram which circumscribe the circle. Okay, so let's draw a parallelogram. This is a parallelogram which circumscribes the circle. Okay, so let's give it a name. We're starting from here. This is A point, this is B point, this is C point, this is D point, the center is O, and the point where the parallelogram touch the circles are P, Q, R, S. Okay, suppose P, Q, R, and S. Okay, now look, as it is given, ABCD is a parallelogram. So from the definition of parallelogram, we know that its opposite sides are of equal length. Means length of AB will be equal to length of CD. That means AB will be equal to DC, and also length of BC will be length of AD. Length of BC is equal to length of AD. Now I think this type of problem we have done once. If you see question number 8, look, there was a quadrilateral. If you have a book, then look at question number 8. There was a quadrilateral which circumscribes a circle, and we have proven that the sum of its opposite sides are equal. Means AB plus CD is equal to BC plus AD, isn't it? Can you remember in which way we will prove that sum of the opposite sides of a quadrilateral are equal? By same method, by similar process, we'll prove that the sum of the opposite sides of this quadrilateral, this parallelogram, are equal. Okay, so we'll start from point A. So as AP and AS are the tangent from the point A, so we can write that AP is equal to AS, and I think you know the reason, that the length of the tangent drawn from a point outside the circle are of equal length. Okay, so I am not write the total sentence, you will write it here. Now from the point B there are two tangents. One is PB and one is BQ. So length of PB will be equal to length of BQ. The reason is same. Now consider the point C. Now see, from the point C we have two tangents. One is CR and one is CQ. So length of CR and length of CQ will be equal. So CR is equal to CQ. And similarly from the point D we have two tangents. One is DR and one is DS. So length of DR will be equal to length of DS. Now add them. If I add this, so left hand side gives AP plus PB plus CR plus DR is equal to, and the right hand side will gives AS plus BQ plus CQ plus DS. Now from the diagram you can see that the sum of AP and BP will gives you the total length AB. So we can write it is AB plus, now look, CR plus DR, it will gives you the total length of CD. So AB plus CD is equal to, now look, if I add AS and DS, so it will give you AD. And if I add these two, BQ and CQ, BQ plus CQ gives you BC. Okay, finally we have proven that AB plus CD is equal to AD plus BC. We have proven this proof in question number 8 also. Now, what is the quadrilateral ABCD? It is a parallelogram. And we know that in a parallelogram, the opposite sides are equal. AB is equal to CD. So in place of CD, we can replace it by AB. So this is AB, and in place of CD, we are writing AB again. So AB plus AB is equal to AD plus, in place of BC, we are writing AD again, because BC and AD are of equal length. So AB plus AB will gives you 2AB is equal to 2AD. Now these two will cancel each other, so AB equal to AD. So we have proven that it is a parallelogram whose two adjacent sides are of equal length. This length and this length are equal. Two adjacent lengths are of equal length. So what type of this parallelogram is? What type of this quadrilateral is? If two adjacent sides of a parallelogram are equal, two adjacent sides of a parallelogram are equal, then what type of this quadrilateral it is? It must be a rhombus, because we know rhombus is a parallelogram with all sides are equal. This side is equal to this side equal to this side, all the sides are equal. So if we can prove that in any parallelogram two adjacent sides are equal, so we can say that the quadrilateral is itself a rhombus. Therefore we can say that ABCD is a rhombus. Proof. Now tell me, any doubt from your side? Otherwise we'll move to the next question. Any doubt? Anyone? If you have any doubt, you can tell me. No problem. Very good. So now we'll solve question number 12. Okay? So just read the question once. Question number 12. So a triangle ABC is drawn to circumscribe a circle. Okay? So let's draw a circle first. Okay, so this is our circle whose center is O, and a triangle is circumscribe this circle. Okay, so draw a triangle which circumscribe this circle. So this is our triangle which circumscribes the circle, and name of the triangle is given as ABC. This is our A point, this is our B point, and this is our C point. I think you can't see the total diagram, isn't it? Can you see the total diagram I have drawn here? Some part we can't see. Yes, I can understand. But can you? A point is not visible. Okay, but consider these two lines intersect each other at the point A. The diagram is also given. The diagram is also given in your book. You can see it from there. Okay, and it is given that CD is equal to, this point is D. CD equal to 6 centimeter, and BD is equal to 8 centimeter. 8 centimeter, and this is the 6 centimeter. And also it is given that the radius of the circle is 4 centimeters. If this is the radius, so radius of the circle is 4 centimeters. What we have to find? We have to find the length of AB. Find the length of AB, this side and this side. Now question is how we can do it. Okay, but before before solving the problem, let's discuss some basic thing we'll use to solve the problem. First is, what is the area of a triangle? Area of a triangle. The formula is half into base into height. Half into base into height. Okay. And in class 9, we learn a formula how to find the area of a triangle whose all sides are given. The formula is known as Heron's formula, and the formula was area equal to under root over of S into S minus A, S minus B into S minus C. We'll have to use these two ideas, these two conceptions to find out to solve the problem. Okay, so let's see how to solve the problem. First, let the circle touches the other side of a triangle at the point E and F. This point is F and this point is E. Okay. Now, we know a theorem that if I draw two tangents from a point outside the circle, so length of the tangents will be equal. So as CD equal to 6 centimeter, so what will be the length of CE? Tell me. If CD equal to 6 centimeter, what will be the length of CE? Exactly. That length will also be 6 centimeter. And as BD equal to 8 centimeter, so length of BF, it will be also 8 centimeter. Clear? Now we are considering that length of AE and length of AF, they are X centimeter. This is also X centimeter, this is also X centimeter, because these are the tangent drawn from a point A which is outside the circle. So length of the tangent must be equal to each other. Clear? Now let's find out all the sides of the triangle. So in the triangle ABC, what is the length of ABC? That is equal to 6 plus 8. That is equal to 14 centimeter. What is the length of AC? This is 6 and this is X. So that is 6 plus X centimeter. What is the length of AB? That is 8 plus X centimeter. Now look, up to this, have you understood? Up to this, any confusion? No. Now, three sides of a triangle are known. We'll have to find its area. So first we have to find the semi-perimeter or half perimeter. Okay, so find the perimeter. Perimeter. And perimeter is denoted by twice of S. So twice of s equal to 14 plus 6 plus x plus 8 plus x. Okay, so s will be equal to, add them, 2 into 14 plus x by 2, that is equal to 14 plus x. So half perimeter or x is equal to 14 plus x. Clear? Now whenever s is known, find the area of the triangle. So area of the triangle ABC. Put the formula under root over of s into s minus a, s minus b, s minus c. Okay, that is equal to under root over of, what is the value of s? Value of s equal to 14 plus x into s minus a. So s means 14 plus x minus a. A means suppose 14. Actually a means 14 into 14 plus x minus b. What is b? B is the opposite side of angle b. So that is 6 plus x. 6 minus x. And 14 plus x minus c. What is c? Opposite of angle c. That is 8 plus x. So 8 minus x. Okay, now just we have to do the calculation. Here 40 and 40 will cancel each other. X and x cancelled. X and x cancelled. That means, so may I rub this portion? I have no space to write. So I am rubbing this portion, okay? So area becomes under root over of, that is 14 plus x into, this is x into, this is 14 minus 6, that is 8, into, this is 14 minus 8, that is 6. So this is the area of the triangle ABC. Clear? Okay. Now we'll find out the area of the triangle in different way. How? By joining CO, AO and BO. We are joining AO, BO and CO. Now look, AOC, BOC and AOC all are triangle. So we'll find out the area of these three triangle, and if I add the area of three triangle, you have the area of the total triangle ABC. So we can write that the area of the triangle ABC is equal to area of the triangle AOB plus, means area of this triangle, plus area of the triangle AOC, means area of this triangle, plus area of the triangle BOC, means area of this triangle. Okay, so let's find out the area. So what is the area of triangle AOB? Okay, so look, this is the radius, which is 4 centimeter, and we know the radius is always perpendicular to the tangent, means this line. So this OE is the height of the triangle AOC. So area will be half into base. Base means AC, which is x plus 6, into its height 4. Now tell me, have you understood how we calculate the area of this triangle? Tell me once. There's nothing else. Have you understood how to find the area of AOB? This is half, and base of the triangle AOB is AC, and whose length is 6 plus 6, into its height. Height means 4 centimeter. Plus, similarly find the area of the triangle AOC. So area of the triangle, sorry, I have written AOB first. So this is 8 plus 6, okay, 8 plus 6. Now half into AOC, this side. So that is half into base, means this is 6 plus x into 4, plus area of this triangle is half into 14 into its height 4 centimeter square. Now from this expression you can take half into 4 common. Half into 4. You can see each term containing this 2 term. So we can take half into 4 common. So that is, it is 8 plus x plus 6 plus x plus 14 plus, not 14 plus, 14. Okay, so now do the calculation. If you calculate it, it will be half into 4 into, if we do the calculation, there are 2x and 24. So it will be 2 into x plus 14. So these two and these two will cancel each other. So final answer is 4 into x plus 14. 4 into x plus 14. Now look, this is the area of the triangle and this is also area of the same triangle. So can't you equate these two terms? Because both gives the area of same triangle. So if I equate this term, so we can write according to problem, this term means under root over of 14 plus x into 8 into 6 is equal to 4 into x plus 14. Okay, now we have to solve this equation to find out the value of x. So first, squaring both sides, we have 14 plus x into 8 into 6 is equal to 4 into 4 into x plus 14 whole square. So 1x plus 14 and x plus 14 will cancel each other. Okay, so 4 2s are 8, 2 2s are 4 and 2 3s are 6. So in the left hand side it is 3x is equal to 3x is equal to x plus 14. That means this is 3x minus x, 2x is equal to 14. That means x is equal to 14 by 2 equal to 7. Okay, so value of x is equal to 7. So this length is equal to 7, this length is equal to 7. Now you can easily find out the values of the side. So what is the length of AC? AC equal to 6 plus 7. That is 13 centimeters. What is the length of BC? BC equal to 8 plus 7. That is 15 centimeters. So the length of the side of the triangles are 14 centimeter, 13 centimeter and 15 centimeters. Okay, students, tell me, have you understood or not? Any problem? Actually, this is very little more lengthy problem compared to the other in this exercise. But the problem is very okay. If you clear your conception, here we have to find the area of the same triangle into different manner. One is by applying Heron's formula, and one's applying by the formula half into base into height. And then we have to equate them. If you do the calculation in the correct process, correct manner, you will always have the correct answer. Okay, so today we have completed question number 12, and actually my times is also now completed. So I am not solving question number 13 today. You try to solve the question. If you have faced any problem while solving the problem, then tell me in my next class. Okay, so this chapter is now completed. Next day we'll start a new chapter. New chapter will be area related to circle. I am skipping chapter number 11. We'll do it later on. Okay. Okay, so see you the next class. Bye bye. Thank you so much. Bye 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 bye.